Day 21, Microarchitectures, Umbraco on Docker, Part 1, by Carl Sargunar. Looking at a full sample of running Umbraco and a database along with additional services in a microarchitecture application. This is the first part of my two-part talk, running Umbraco as part of a microarchitecture application. I'll be discussing the pros and cons and going through an example you can run yourself, which is pre-configured to have the website, a database, as well as an API, all working together on the same application infrastructure.
Hi, I'm Carl, and welcome to my talk, recorded for the 24 Days of Umbraco 2021. So, in this video, I'm going to be looking at microarchitectures and hosting Umbraco on a container-based application compared to the traditional monolithic application that we've used to host websites before. It's the first of two parts. This is the first. This is me. I'm Carl. You can find me online mostly on Twitter, but I also have a blog which I update every time I remember to, not as often as I'd like. So, what are we talking about today? Today we're going to be looking at the concepts of containerized applications versus monolithic applications that we've traditionally built. We're going to look at what Docker is, how Docker works. We're going to take into account some of the things you need to know about Docker, storage, networking, how you work with databases, how you work with services, that kind of thing. So, what is Docker? Well, Docker is a set of platform as a service products that use OS level virtualization to deliver software in packages called containers. That's from the Wikipedia page on Docker. The containers are isolated from one another. They bundle their own software, libraries and configuration files and can communicate with each other through well-defined channels. And that pretty much describes it pretty well. One way to think about them, little virtual machines. It's not entirely correct. It's close enough. So let's look at what the difference is between a traditional virtual machine setup versus Docker is. In a virtual machine setup, you would have your main your main computer, your kind of host, which has the hypervisor on there, which effectively virtualizes the hardware and then lets you create multiple virtual machines off that hardware. So you might have one virtual machine for your website, one virtual machine for your database, and maybe a second website which could be a load balance between the two. Or maybe that's an image cache service or a search service or an API, something else. Docker works slightly differently. On a traditional virtual machine environment, each VM has to have its own operating system. That isn't there on Docker. Each application effectively uses the Docker infrastructure to use the operating system of the host machine. So it doesn't need to replicate that. Now, that has strengths and weaknesses. It does mean that if you're on a Windows machine, you can, through the use of the Windows subsystem for Linux, host both Windows and Linux Docker containers. But you can't host a Windows container on a Linux operating system, host operating system, because Linux doesn't have that kind of those Windows API calls. They're natively available to it. You can only host Linux containers on Linux. So, what is a monolithic architecture? I mean, it's a traditional architecture that we've used for many years to build large websites or small websites. You know, you have your user interface, the back end, the API, maybe your business logic level, maybe not, and database below that. It's traditionally normally deployed all at once. You have a big bang release every time you make some changes. So every time I add a new feature, add a new service, I have to deploy everything in one big go. Not necessarily always, but the code base can get fairly complex for large applications. It's not unusual to have dozens and dozens of projects in an application. It can be harder to test. specifically around things like regression. Yeah, unit integration testing is a big one. Snapshot testing. Because of the complexity of setting it up, because of the complexity of setting up staging environments and things like that, it can be harder to test these monolithic applications, and they can be resistant to big changes, because it's all, again, one big thing. Scale is a problem. If I need to add extra resources, I can either scale upwards if I'm on a virtual environment, but not if I'm on a physical environment. If my servers are dedicated servers, I can't scale them up so easily. To scale outwards, to basically create a second machine, that's an extra level of cost, but then you also have to take into account things like load balancers, which is extra hardware you have to put into place. And there can be barriers to new technology. If I want to do something differently, I can do that as long as my operating system and the technology that I'm using is compatible with that, but maybe that's not the case. But the big caveat here is there's nothing wrong with a monolithic application to host your websites. As I have plenty of hosts myself, currently on the same application architecture, and it works absolutely fine. Containers are just a different way of looking at things. So with a container, you traditionally will have your application, and then any networking containers and storage required to go with that. But your application is broken up into individual pieces. So you might have one piece for your website, one piece for your database, one container for your search API, one container for a Redis cache, maybe. You break your website up into individual pieces. The key here is that each piece can be independently deployable. You don't have to deploy everything at once. You can make changes to one part of it and deploy just that. That works again really well with the single responsibility principle. Your individual pieces are also fairly loosely coupled. For example, maybe I have a service that I use which sends emails through, for example, SendGrid, and I want to change that to use MailChimp. I can just replace that container without having to redeploy everything else, the website, anything that's associated with that, and just change that one container which does the email sending, and that's it, it's done. And I can test that independently. I don't have to test the entire website. I don't care about the rest of the website, because all I'm doing is just one job. I'm just building an email sending service. Not restricted to the same tech stack. This is really, really cool, because it means that you're not I can build my website in C#, but I can still use APIs that are built in Go, and I can use services that are built in F#. I can use whatever tools are available to me, and whatever tools my team are comfortable with. It's repeatable in the sense that if I do something and build it in my dev environment locally, if I take that container image and I deploy that to the staging environment or the production environment, it's going to be exactly the same, because it's exactly the same code running in each piece. And because each container is a small piece, the code base associated with that container is appropriately smaller. I only have to consider the API for my email sending in the earlier example. I don't care about the rest of the website. And if I'm working on the email sending, I don't have to have a project open with all the entire website there. I just have to have code for my email sending and any tests associated with it. That does add more complexity, and that's where the asterisks come into it. So it's not a better solution. It's just different, with different strengths and different weaknesses. There's a few Docker concepts that are useful for the audience over here at this point. A Docker image, which is effectively a read-only template for creating a container instance. It is the definition of what goes into your container. A Docker file is effectively a set of instructions that are needed to build that container image. So your website and all the code that's associated with it will also include a file which is a Docker file, which includes instructions on how to build that container image from there. And we'll look at one later as an example. Includes all your settings, parameters, instructions, keys, URLs, that kind of stuff. And Docker Compose is effectively used to create related images which work together to make your application. So whereas a Docker file is responsible for a single image, Docker Compose is responsible for your entire application. It uses a CLI tool to manage your application both locally and also in CI/CD pipelines in production environments. This is one thing you'll may see old documentation which refers to Docker-Compose, but that's now been changed to Docker Space Compose. So they're interchangeable. The new way of doing things is with Docker Space Compose, and it uses everyone's favorite data structure, YAML. So the demo. Today I'm going to be creating a very simple container application architecture which is based on 3 websites, predominantly an Umbraco website which will host our application. There'll be an API associated with it which is going to be just a weather API, and a SQL Server container which runs that application. So let's go look at that demo. So to get this demo up and running, you're going to go to this URL up here, GitHub/Carl Sargunar /Umbraco-Docker, clone the repo. It's got the basic notes, including things you'll need. Specifically, you're going to need Docker Desktop for Windows. If you're running on Windows, there is also a Mac version. If you're running on Mac, on Windows, you're going to need WSL for Windows, but that's installed as part of Docker. And I find VS Code to be one of the most helpful UIs in working with this. So I'm just going to clone that repo here in a fresh folder. Whilst that's running, I'm also going to fire up Docker Desktop. So you can see that I don't have any containers related to this project. The containers that's there is just my internal dev SQL Server. So I'm going to open up this project in code. And you'll see there's the structure inside here is the kind of the main README, which is the same on the website. And I've got a solution file which kind of has the solution for the entire project, and everything's kind of kicked off from this main Docker YAML file. This Docker YAML file effectively manages the deployment of all 3 containers inside this application. If you recall, this demo is going to be an API which is used by the website, the main Umbraco website itself, and SQL Server, all within the same kind of network. So these same 3 pieces are represented here. You've got your database, which has its own Docker file, which is inside data Docker file there to install that. You've got the main Umbraco website itself, which is inside its own Docker file inside here, and these Docker files are what are used to actually create the containers and the images for the containers themselves. And you've got the weather API, which is got again its own Docker file inside here. So yeah, the Docker Compose file manages the entire application and sets all 3 containers up. It sets the ports that they listen on. It sets the networks that they are. It sets the name of the actual container themselves. It also sets volumes. Now these are really important, particularly in the case of the database, because once a container shuts down, any files internal to that container are destroyed. But if you want to maintain your database files whilst you restart your container, or if you have to recover from a crash or something like that, by storing the volume, the database files in a volume, they're still available once a container restarts. So to fire this up, I'm going to open up a terminal, and I'm going to, where is that new terminal there? I'm going to run from the command docker compose up -d. What that's going to do is that's going to run through the 3 installation Docker files there, that one for the database, this one for the website, and this one for the API container, and you can see it's actually already done that really quickly. So I can now go and see that from inside here I've got this new application that's up and running. It contains my 3 containers. The API is listening on port 5081, SQL Server is listening on port 1433, and the website is on 5080. So if I fire up Firefox, I should be able to go and look at the weather forecast API. This is just to see kind of what the weather forecast is doing. To demonstrate this weather forecast API call, what I've basically done is inside the Umbraco website, I've first of all used Paul Seal's template. What was it called? It was, I should know this, sorry Paul. It was called the portfolio package, which is the portfolio sample website. I've got some instructions on how to recreate this repository from scratch yourself if you don't want to just clone mine and use it. So yeah, I've taken Paul's portfolio package and I've just extended the homepage controller to call my API, and just in the temp data response, as a quick and dirty demonstration, send the response back. And all this will do is we'll take these responses, serialize them, deserialize them into an object and send them back into the view. And all the view will do is take that data and just render it out on the page. So let's go and see if that is up and running. Okay, so this is the portfolio website. It's a standard Umbraco website. I can kind of browse around all parts of it. I can see homepage, and down here you'll see the weather API response. Now this response is from my website application container calling into this container, and then that returned the response over there. To give a very quick example of how this is super useful, say I want to change that weather service, maybe it's using, I don't know, BBC Weather to get its weather data, and you want to change it to call some other weather service. All I have to do is change the code for that container, which in this project is all in one solution because it's a quick sample, but this could very easily be a completely isolated container itself. And then redeploy that, and then I'm just effectively swapped one container out for another service. In the same way, you've got access to full Umbraco, so I can go to Umbraco, log in with the credentials. Those are all on the README page, and yeah, you can see it's just a fairly standard Umbraco site, but it is all running from these three containers. I can also open up these containers and I'll see the logs that are being fired off from here, and yeah, there's a few errors and things to deal with, but again, this is a sample, but you can kind of see what's happening. And I can demonstrate it all by killing these containers, and then once they're dead, all these sites will stop. They'll just keep spinning in timeout. They will no longer respond. There you go. Cool. So that was a demo. So to recap what we just looked at, we looked at what a container is and how that compares to a traditional virtual machine. We discussed some of the benefits of containers, how they're independently deployable, testable, reusable, all that stuff. We ran Umbraco in a container as part of a larger application. Now the code for this is available online. It's at that URL, so I'll also send links out to this on Twitter later, etc. Do take a look, and I'd welcome any feedback on that. I'm not a Docker expert. I'm learning just as the audience is too. So yeah, have a look. And obviously I'll caveat that this is, not a production setup. I've done this as a learning exercise, so any advice inside here is just for that. Docker and containers are a huge topic, and there's a lot to learn over there. And yeah, just keep an eye on my blog. I'm going to continue to create more and more articles and videos around this, so come and say hello. What's in part 2? Well, you're just going to have to come back and have a look. It's going to be exciting. Thank you very much, and I hope you all have a wonderful holiday season, and see you all soon.
All the code for this demo is available at GitHub, and I would welcome any feedback. Any problems running this code, please reach out to me on social media. Thank you.